Hey guys, so this series seems very popular, yeah? The eBay spares or repair investigation as to what will you get if you buy a load of cards off eBay. So 13 bought, and this is the third one. So this was the batch of 10 that all came together. €100 plus, sorry, £100 plus £9.50 postage. And this is actually the eldest. This is the oldest of these, apart from this one unknown small GPU, which we will look at. So this is the GTX1070. Yeah, I fixed one of these before. I think it was a 260 that I got from the flea market. One of the very, I think it's quite possibly the first GPU I have looked at on the first video on the channel. So I'll link that one, and then you can see how things have moved on since my first faltering steps into YouTube video production. Yeah, and I'm sure I've got a long way to go to get it really right, but anyway, okay, so this is the one. And the last one I did during the visual inspection, I didn't do a very good job of it, to be honest. Once I reviewed the video later, I found quite a lot more broken off capacitors on that one. Not that I think it's really related to the actual fault. So this is the card. It could be, as he said, all spare repair, some display picture on BIOS, no further tests. Well, so far 2 out of 3, well, 2 out of the 10 look like they're repairable. They're both waiting parts now. I haven't found any blown GPUs yet or short circuit VRAM. But I haven't found one that gives a picture off on the BIOS either. So let's stick with the routine. Yeah, the routine. We've got a routine now. So open it up, visual inspection. Let's have a look, see what we've got here. Oh, just as I'm doing that, I'll put the video back on. There's 2 screws missing here. There's 2 missing here. So we can say that once again, somebody's looked at this one previously, or at least had the fan off. If we give them the benefit of the doubt, let's say they've had it off to clean the fans, yeah. But in that short time, they managed to lose 2 of the screws, which is not very good going, is it really? So, seeing there's quite a few to remove, let's just pause the video for a moment and then carry on. It was a bit hard to get into that one, actually. And I think in the end it was just this sticky holding it on, yeah. It's a little bit moist, the compound. The bit in the middle that seems very dry though. That doesn't look like it's been changed. All the pads seem to be physically on the card, yeah. It actually goes this way around. So all the thermal pads seem to be there, the little ones down here for this chip. And another one here goes up here somewhere. This chip, by the way, is involved with the SLI communication. So this has got the SLI connectors on, and that's what this chip actually does. I've seen it before because I've seen one of these before, and previous I didn't actually know what it was. So that's what that is. This is the GPU, obviously the RAM. We have, looks like 4 phases here, which is going to be for the core, I would imagine, yeah. Low side pairs of MOSFETs, yeah, if you watched the last video, and high side MOSFETs for each one. This is probably just a filter on 12 volt, but it could be a 5 volt regulator. A couple more down here. Any on the back? No. So one of these is probably 1.8, one might be PEX. Then there's another controller here, which I'm kind of guessing is either probably the VRAM or memory controller. I'm not quite sure what they had on these older generation cards. But that's what we basically have on here. Let's have a visual inspection. We'll try it with the overhead camera first. Okay, just a quick look. I'm really just looking for any burnt components or such like. I don't know for something here. This might just be sticky kind of stuff, oily stuff off the thermal pads actually. Nothing burnt as such, I think anything obvious. These are the VRMs. So the controller is going to be somewhere. I'm guessing that's on the other side of the board. Let's have a quick look at the other side of this, so you can see. I think it's more likely to have broken components on this side of the board, because this is basically to get like the most hammer, if you like. The other side's protected by the heatsink, basically. This, I'm guessing, is the controller for the V-Core. These are all too small to see, so we'll have to get this under the microscope and have a look in this area, see if we can see any broken off components, but it's all clean anyway, yeah. And the same over here. Oh, let's get the microscope out and let's have a look to see what we've got. I've just taken the back bracket off this one as well. It just helps it to sit a little bit flatter on the desk when it's under the microscope, so it stays better in focus, yeah, when we're running across the board, so it's not sloping, yeah. Okay, so let's have a look. I'm going to use the eyepieces because it's a little bit easier to spot things this way. But it's in focus for you on the screen as well, so you should be able to see just as well. Let's have a bit of a look. We'll go up and down the board just to see if I spot anything obvious broken on this one. I probably will when I come to review this video, by the way, which is what happened on the on the previous repair, yeah. For some reason, that's when I tend to see them. Perhaps I should do that every time and just video it and then sit and watch the screen. I don't know. It looks quite clean at the moment. Obviously, it is easy to miss something, you know. Nothing shouting out at me, unless you guys are shouting out at me. It wouldn't surprise me, yeah. Let's see. So this like this Q509. I don't think anything was ever actually mounted here. I mean, sometimes it can be hard to tell. It looks like somebody might have soldered the capacitor here. Interesting. No, there's a few of them that look a bit like that. I mean, it just looks like maybe a bit of soldering's gone on, but you can't. It's hard to tell. I mean, you know, if it has, they've done a pretty good job of it and cleaned it up afterwards. Let's have a look down this side, see if we've got any more, anything else we can spot. All the capacitors seem to be present on the bottom edge. Nothing obvious up here. Okay. Okay, let's have it down here. Almost looks like somebody's trying to like unsolder one end of that, but you know, it's hard to say again, yeah. Ah, okay. We have a problem. So something's burnt out here. I mean, this one and this transistor, yeah. I'm not sure I can make the markings out on this now, but this looks like maybe some sort of VRM controller. Oh no, hold on, there's one there, there's one here. Are we underneath the, yeah, we're underneath the phases of the RAM, yeah, the VRAM. So we're underneath these two phases, which is near the bottom edge of the board, yeah. So here's the PCIe, yeah. So in this area, this must be a driver chip. This is a transistor, I'm guessing. It says D505, so it could be a diode. These could be diodes. Another one the same there. Another one the same here. Another one the same here. So let's have a look for shorts or problems in this VRM. Yeah, looks like we've got something wrong here. Okay, that was well worthwhile. Let's see what we find with the resistance meter then. Okay, so let's do this the usual way, yeah. I'll just straighten this camera one moment. There you go. Okay. So we'll check first from the 12 volts and 3.3 is coming in, yeah, looking for shorts. I mean, obviously we know there's a problem with the drivers under here, but still. So ground 12. Let's put this where you can see it. So ground 12 volts. And that's like half a meg. That's high, yeah. That's on the first three fingers. 3.3 is on the fourth one in here. 1k. I mean, that's reasonable. This probably is a 5-volt regulator, 12 in and 5 out as a guess. So I'm just having a quick look. Could probably be a short on the middle pin, which is probably ground. No, it isn't. Okay, fine. Well, there's no shorts there anyway. This is the other guessing mem. It's 26 ohms. Yeah, I know. Yeah. Let's settle down. Come on. 26 ohms. I wonder if that's the RAM. I'll check what make this is. We can sort of kind of find that out anyway. So these two phases up here are reading 0.7. Now I know, and I'll link the previous video on one of these, that the voltage core on these is very low anyway. Yeah, so I wouldn't necessarily say that was a short. Yeah, 0.708. I'm pretty sure that's what I read on the other card. Yeah, and this is appearing on all four phases here, I'm thinking. Yeah. Yeah. So I'm not thinking that's a short on the V core. I know this particular type reads quite low anyway. A couple of other coils down here we can have a look. That one's quite high. There's another one here. 16 ohms. Wonder if that's a PEX supply to this. Yeah. Or the 1.8 maybe. I can't remember exactly on these older cars which supply rails they have, to be honest. There's another one here. This is reading pretty much open circuit. No, I wasn't on it. Yeah, it's a high resistance. Anyway, see which side that is. Pins are, it's a bit hard to see. Oh yeah, the pins at the side of it. I think my looks of it in there. Yeah, it's still a high resistance. There's another one up here. That reads quite a high resistance. So I don't see any shorts on this. Now, it's interesting to see whether there's going to be a short on any of these MOSFETs, yeah? So, go from the 12 volts first. So let's see where the 12 volts comes in, which is under here. And this is probably going to the top of these MOSFETs on that one. That one. The other connector might go to the other ones. Yeah, so let's try the other connector. Yeah. So we've got two phases running on one and two phases running on the other of these, yeah. And there's no, well, let's check if there's any shorts. So from here to ground. So I don't have a shorted high side MOSFET. If I did, you would see the short on all of them, even though it's just one of them, yeah. So none of those look to be short, okay. From the tabs of these, they're sort of effectively like the junction between the coil, these two, and the source of those, yeah. This is where you'll see the 1 ohm resistor, I would think. Oh, that's interesting. 12, what else have I got? 10, 7. Well, for some reason, I'm assuming it's my meter not making a good ground. I'm now reading different resistances than I was before. Better, isn't it? That's better. Okay. 0.8, 0.7. This is what I expected to find. 0.8, 0.7. And the other side of these will be ground. Well, there'll be a gate. There'll be a ground. Yeah, ground, ground. A good indication we've got a problem with MOSFETs as well is to measure the resistors from the gate to ground. Yeah. They should all read the same, or at least the low side should all read the same, and the high side should all read the same. So this is one of the gates. 15.18k. What's this one? Close, yeah. Close. This one is completely different. So it's looking like this bottom one has the problem. That's probably where the burnt out chip is. Could be the burnt out chip affecting it, so I think we're going to have to actually take them off the board and test them to be absolutely sure. Yeah. Let's have a look on the high side gate. So this is a high side gate. This will be the high side source, which is ground. So you can easily find that. So this is the high side gate. You know what we got? 6K. 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 Was it 6K? Yeah, close enough. 6.1. And this one again has a problem. Yeah, so these seem to have a problem compared with all the others. Is this where the burnt out device is? Yes, it is. Okay, so what we're going to have to do with this then, guys, first is to take these three off and have a look. Yeah, I'll just want to show you something else as well, which I don't think is going to help us at all in this case, but this is an ESR meter. Yeah, now with the just put them back on. With the DVM, yeah, voltmeter on resistance range, you cannot see which side of the inductor coil is a short, because the resistance of the coil is so low to your multimeter that if you go to ground from either side, yeah, so we go from this side of the coil, 0.6, yeah, 0.6, yeah, you really don't see any reliable difference, yeah, and that'll be true on all of them, yeah, including the one that's got the problem. Okay, good ground. This meter's definitely got a problem with a lead today, guys. 0.8, 0.7, yeah. 0.8, 0.7. So I'm not seeing any difference really on any of the coils. Now, the ESR meter is meant for measuring capacitors, yeah, and it's meant to measure the resistance of a capacitor by putting a 100 kilohertz frequency signal through the capacitor and measure the resistance at that frequency. That's the ESR, yeah. But we can use this the opposite way around in this case. An inductor to the 100 kilohertz frequency will have a resistance. So we can actually see which side of the coil is the low resistance without taking the things off, yeah. So let's have a look. So this is reading, just get a good connection on it, I think it was 1.4, 1.19, 1.2, yeah? $1.2, yeah? About 1.2, okay? On all of them, yeah? Now let's go to the other side of the coil. 1.09, 1.08. So we can see the resistance is lower this side. Now it won't work exactly as you think because there's capacitors on this side and that side, yeah. But most of them on this side of the circuit. I mean, they're all over the place, but there are plenty here as well. So either side of this coil, depending where the capacitors are, you'll get a path from the side of the coil to ground via the capacitor. But on this side, basically there's just these, yeah. On this side there's lots of them. So the capacitors themselves will go a lower resistance path to ground. And that's exactly what we're seeing here. So from this side of the coil, 1.08, and from this side of the coil, 1.19. And that's because these capacitors are still conducting to ground at 100 kilohertz, but the signal has to go through this first, and this is a resistance at 100 kilohertz, yeah? Hope that was clear. My explanation was slightly muddled, but hope that's clear, yeah? So we can see that the lower resistance is on this side, which is below the GPU, and we know that these GPUs, or I know, this particular one has a very low resistance, about 0.7 is normal, yeah? So that demonstrated the point, which I wanted to demonstrate, a point to you there, that using an ESR meter is a very good way to find out which side of an inductor coil is the low resistance, is the short. It only works when it's a very low resistance or it's a short. If you've got 10 ohms or something, it won't give you a reliable reading, and that's because that's sort of when the resistance is higher, DC resistance, the actual capacitance starts to have more effect. Yeah. Anyway, there you go. So let's take these off here and let's see what we've got. Okay, so just as chance would have it, somebody on the comment on the previous video asked me about removing MOSFETs from GPUs, and he said he had a, I think it might just be like a 350 watt hot air gun. He says he can't unsolder them, and I kind of said I'm not surprised. Yeah, these areas of these boards will take a lot of heat and they sink a lot of heat, and it's difficult without the right equipment to get enough heat into the job to remove them. But I'll show you on this one. For the benefit of, I just can't remember the guy, but yeah, I'll help any subscribers if I can, how to do it. So the first thing we notice here is next to there we have two electrolytic capacitors, and take my advice, you need to take these off the board first. If they're this close to it, take them off the board, because the amount of heat we're going to get into this is quite high, and it's quite possible one of these will explode. Yeah, I've had this happen. It's not nice, and you really don't want to do it again. Yeah. And it's so easy to remove these capacitors and replace them, you might as well. That's my opinion. So to get the capacitors off first, quite simple. They're just here. I could just do the one that's closest, but I'll do the two of them. They're both the same value, they're both the same way round. So a little bit of flux, a bit of solder, and try. I'm sorry, the soldering iron's gone to sleep one moment. It is on. Okay, I've got some flux on them. I've actually put some solder on this one now without unpausing the video. But anyway, basically the trick here is to get a blob of solder big enough to sit right across the capacitor to shoot the two pins together. Yeah, we'll do the same on the other one. Yeah. So if you just get a blob to sit right across it. There we go, it's big enough. Right, once you've done that, you can then get hold of the capacitor. Make sure it's not too hot, yeah. Just set the focus a little bit for you, and you'll see it. Let's focus on that. There you go. Yeah, so get hold of the capacitor with your fingers. Hit the blob of solder, and it'll melt both sides at the same time. And they can just pull it out the board. Yeah. If you get it's a bit warm, then use a piece of cloth or something just to hold it. Something like this, yeah. Don't use pliers. Chances are you'll crush the capacitor or you'll damage it. You might even cause it to have an internal short circuit, yeah. And you won't notice, and then you will notice when you put it back in. Yeah. So just get a bit of heat into this, get a bit of cloth. This one's quite tricky, but it will come. You can see now how much heat I need to get into this to do this. Yeah, this will give you some idea of what's to come when we remove the MOSFETs. Yeah, and you'll understand why I'm doing it this way, taking these off first. So that one's off. Yeah, same with the other one now. So a good amount of heat into this blob of solder, and then it'll start to come loose. This is why you need the cloth. Yeah, there you go. Off. Yeah. Okay, once you've done that, we're now going to just clean this big blob of solder up, because so it doesn't kind of like become a solder ball and wander across the board. Yeah. There's quite a lot of solder obviously there, so we'll just find some cutters. Should have had them to hand. There we go. Okay, so. That's got the worst of it off. Obviously I'll have to clean the holes later. I'll use the vacuum tool to do that. You can use solder needles as well. But anyway, let's clean it up, yeah. So the capacitors are off, that's safe. They're not going to be exploding now. So now we need to desolder these. The way to do it, in my opinion, and others let me know what you think, leaded solder, yeah. Normal 6040 leaded solder. Get it onto the pins of the MOSFET. Use a bit of flux as well, so it'll help you. Get a bit of flux in there, okay. So get some leaded solder onto the legs of the thing, yeah. 1, 2, to be, yeah. Okay. Right. So that's some leaded solder on them. Okay, now what we're going to have to do is to preheat the board, because you'll struggle. I mean, I have a quick 861DW, which is a decent hot air station, yeah. It'll do it probably without the preheater, but this is much kinder on the board. I'll just zoom out and I can show you what it is. Okay, so this is the one I use. This is a Canaria 853B from AliExpress. They're quite inexpensive actually. It's not an amazingly powerful thing, but it's great for this sort of work. So I need to balance the board here. What I normally do is just prop something else underneath it, just so I can get like a, there you are, yeah. Maybe put it diagonally, so that the things I want to remove are over the hot air. Okay, and the last thing I'm going to do is just use a temperature meter. Can I get this in the shot somewhere where you can see it? I'll have to zoom out a little bit to do it, yeah, but we can do that. Let's just get this so you can see the temperature meter, yeah. There you go. Okay. What do we want in focus? You want the job in focus, but you can see the meter. Okay, so that's the temperature in the workshop, 25 degrees. The air conditioning is on actually. So switch on the preheater, and now we just need to get us up to about 100. Yeah. You can just rest the thermocouple in there if you want somewhere. Yeah. And just turn the heating up. Move it over the heat a little bit better. There we are. Obviously, it's going to slide off like that sometimes. Yeah. So we can just stick it back in here. And stick it in an angle where you can see the heating, yeah? There you are. Just turn the heating up. And I want to get this up to about 100. Once it reaches 100, we'll get the hot air. So the hot air I'm going to set to 450 on maximum airflow. Okay? It's warming up nicely now. I could pause the video, but there again, you can always hit fast forward, yeah. What can we talk about? Weather's been a bit iffy here lately. It's been quite a lot of cloud, and that's unusual, yeah. We get some mixture of sun. We had one cloudy day all day, and that's like something you probably only see a couple of times a year here. If that, in fact, I can't remember the last time I saw a cloudy day. It was cloudy all day. But it's still about 18 degrees, which is below average. 18, 20, some it's been 20, 21, 22. Which is winter-ish, yeah, as much as we have. Okay, so after that waffle, I've just turned the heating up. And I'm going to get us up to about 100, yeah. Once it reaches 100, I'm going to turn the preheater up more, so it's pushing more heat in from underneath. I'm going to get hot air, and I'm going to take these MOSFETs off, yeah. And because I've got the leaded solder on, these should come off before any of the lead free on the other components melts, yeah. Okay, so let's turn it up a bit, yeah. So we're getting there, I mean, it's not exact. I mean, that's getting up towards 100, yeah. So I'm happy enough with that. So that's about 100 on it. You know, you got 100 degrees on there. Turn the preheater up. Get the hot air. Get the tweezers. And this is how to do it, guys. So these three should come off here now quite easily, as the theory goes, yeah. And I've still have to get some heat in to do it. You can see that. See, that's one. This one's already off, yeah. And that one's off. Okay, guys. Now we turn the heater on the preheater off, so it's now blowing cold air. And we just have cold air coming in now, and that's done. I don't think I knocked any close by components off the board. I'm pretty sure I didn't. So I've turned the heater off now. I'm just on cold air now, and I'm just going to let the fan cool the job down, yeah. Well, you can see it's down to about 100 again, yeah. Okay guys, and for the guy who asked, that's how you remove MOSFETs from a GPU. This is the graphics card then after we removed the MOSFETs. You can see it's come out. I mean, I haven't even cleaned it up with the soldering on. That's just how it was afterwards, yeah. So it's made a nice job of that. The resistors are still in place. Nothing's desoldered or blown around, yeah. So that really is the way to work on these cards. So we need to have a look at these MOSFETs now and see what they are and see what condition they're in, yeah. So these are our 3 MOSFETs. I'll just get the microscope then we can actually see what they are. So we have the 3 MOSFETs, and very commonly, I'm sure in this case, we'll have 2 the same. So these two 58NAG, yeah, and then the other one is a 63NG. So this one, the different one, that will have been the high side, but we can always look at the the other channels in the VRM and see what goes where. But I'm sure these two that work together, and this was the high side. So now we need to have a look to see what's the condition of these MOSFETs. I'll just put the meter a little bit further in. So I have the meter on diode mode. I'll just get into view. There it is. Okay, so let's have a quick look at these low side. So this pin will be the gate, yeah, the one here. This will be the gate, and then you'll have drain and source one way around or the other. So we can just go from the tab to here. Yeah, that's drain to source if you like. Now what we can do, oops. What we can do is we can flick it back in here. I'm playing tiddlywinks with MOSFETs here. So yeah, what we can do is if we go from the tab and we just touch the gate, first of all it should be open circuit. Yeah, it should be open circuit. Okay, but secondly that should turn the MOSFET on. Yeah, so the MOSFET's now on. And then if we touch the gate with the black probe, so the other polarity, just gate in place. Yeah. Then it'll turn it off. Okay, that's a good MOSFET. And I'm going to use the microscope eyepieces because it's much easier for me. I don't play tiddlywinks, yeah. Okay, so let's go on the next one. You'll see how much easier it is with the microscope rather than a screen, yeah. This should tell you not to buy a USB microscope, to buy a binocular one. Okay, so MOSFET is off, yeah. Drain to source. Touch the gate. MOSFET is on, yeah. Touch the gate with a black. MOSFET is off. That's another good one, yeah. So look at this one. This is the high side. So again, drain to source, yeah. The red lead goes on the drain, by the way, when you're doing this. Drain to source. Well, the muzzle switch is on, it doesn't actually matter. Okay. So this one has a short circuit drain to gate, yeah. But drain to source is not short circuit, yeah, that's open. Okay, so that's what's wrong with the MOSFET, and that explains a few things with this. I'll show you on the board. So what's happened here is this one from the sorry, off the screen. This one, yeah, from the drain to the gate was short circuit. Obviously, it was the MOSFET. You don't need a short here now, yeah. So this will be the 12 volts, yeah, and we can prove that. I'll just show you. Back on the overhead camera, it's a bit easier to see it. So this will be the 12 volts, so this will go to 12 volts somewhere on one of the connectors, this one, yeah. They may both be in parallel, I didn't check. But no, it's on this one, so that's 12 volts going to there, yeah. And that 12 volts is shorted to the gate, and this gate is what's connected into here, yeah. So the 12 volts has come back through the gate, back into this driver chip, and it's blown this driver chip, and it's blown this transistor as well. So what we need to do is, obviously we need to replace the MOSFET, and I'll talk about that in a minute. We need to replace the driver, we need to replace the transistor, and we may also need to replace this, which is controlling all the phases, because it could have gone all the way back to here, you know, we don't know. So let's have a look to see what parts we need for this. So this is where the damage is, and this is where effectively the current's gone to when it's gone short to the gate. So these two look like the diodes, yeah. I'm just on diode mode. Let's have a look at this one. That reads like a diode, and it probably reads like a diode this way as well. Are these pins connected together? No, open. I don't know what the device is. It's also reading a bit like a transistor, yeah. But I'm sure from that code we can find out. This one is obliterated and you can't read it and it's short, yeah. This device is the same as this device, so we can see L3E G54NN, G54NN, okay. So if you look at this circuit, WW1, like World War One, this thing, WW1, and yet this is the one that looks like it's been in the wars, yeah. Okay, so up here, WV3, WV4, so they're different part numbers, but this circuit looks to be the same as this circuit, so you can see a couple of 2R2 resistors, two of these, yeah. And we have the same up here basically. Yeah, two of these, couple of 2.2k resistors, one there. So I would have thought, to be honest, that these devices are the same as these ones, although they actually appear different. So how did they check? Probably read like a diode like the other one. Yeah. Is this one the same? No, this one's different to the other one. So they are different devices. Yeah. This one's reading like a transistor. So we need to find out what the devices are that go here. Now I just happen to have, I'm pretty sure, another one of these boards. I certainly have another one of this type of GPU. I'm not sure if it's the same brand as this, but I can have a look and I might be able to get it from there. Otherwise, this is going to be going on the internet again. So I'm suspecting, well, we know we need to change this, we need to change this. We may well need to change this as well. And the other thing you should look for when you have this sort of thing happen is resistors, especially low value resistors, to see if they've got open circuits. So we'll do this on ohms range, which won't bleep, but be able to see the value of the resistors. Yeah, and I'll check it without on the screen in a minute because I haven't got my glasses on. Yeah, those ones and these two. Low value resistors obviously will pass quite a bit of current, yeah, and they can just blow without visibly blow. I mean, normally they expect them to burn up, but it's worthwhile just checking around this one and then checking around the other circuit just to see that we get the same readings, yeah. Well, obviously we've just measured these, so they're okay. Yeah, that's the other one. Okay, so check the low value resistors. In fact, just check resistors. The other thing about this particular fault is the MOSFETs. Now, on the MOSFET side, we know it's actually gone short circuit to the gate, but this is not short circuit drain to source, which makes me think that all the other transistors are probably okay. What can happen is if one of these goes short circuit drain to source, it puts 12 volts onto the the top side of the low side MOSFETs, the top side of the low side MOSFETs, yeah. And when these turn on, effectively they'll be feeding from a short. So one of these going short can quite often damage some of the lower side MOSFETs. And you may have a situation whereby when you replace the faulty one, the blown one, you switch it back on, some other ones go. I've got to order these anyway, and I'll order a pack of 10 normally, so I'll have a few spare ones. And while I'm at it, if they're cheap, I'll just get some of these as well. I mean, then if push comes to shove, we can replace all the MOSFETs. But really, that situation would normally only arise if this is short circuit, from drain to source, and the 12 volts has gotten here. Also, another good indication, because this is not short drain to source, the 12 volts hasn't got into the GPU, yeah? It hasn't got that far, so that's a good sign. Okay, so let me have a look, see what these parts are and figure out what we need to order, and then I'll let you know how much it's going to cost to repair this one. Okay guys, just before we continue, You'll notice there I couldn't actually see the meter readings on those resistors when I'm looking down the microscope. Because I wear glasses, it's difficult for me. What I really need, by the way, is a microscope with a HUD display built into the eyepieces. Amtech, whoever, yeah, just think about that one. That would be superb, yeah. HUD display in the eyepiece for microscopes. Okay, anyway. If you're quite sharp-eyed and sharper-eyed than me, you'll notice one of the two resistors is reading high on the bad phase, yeah? That has almost certainly gone high because of the failure. The other little black unmarked ones may well have been capacitors, and some were reading short on the bad phase. Now, that may well be because of the short circuit diode, probably a diode, yeah, that's on whatever rail that's on. But just mention that, so that makes my point. You know, check around the resistors in that area, especially low value ones, because if you miss that, the chances are when you plug this back in after you've spent the money to replace the parts and the time to fit them, it's going to go pop. Yeah. Okay, let's carry on. Okay, I had a look on AliExpress. Yeah. These parts, so these are the actual codes marked on the two MOSFETs, the low side and the high side. This is the one that's actually blown, one of these, yeah. This was the driver chip, I've got one blown, and then these are the transistors or diodes, but the one that I have, I'm not sure what the part number is. So just having a look at these and just wondering why the focus on this camera is drifting off on its own again. It's a blurry day. Okay, so these are fairly expensive by my reckoning. I mean, €10 for 10, but this is with the VAT that automatically gets added for people in the EU now from AliExpress, because your government's decided to rip you off, basically. So I'm fortunate being in the Canary Islands. I don't actually pay VAT, and when I go to check out, it knocks the 21% in Spain actually back off again. So 10 for €8. This is the one that's blown, yeah. So 10 for €2.53, because again I don't pay the VAT that's in there. And this driver 5 for this price, again I pay €3.03. Because of the nature of the fault with this, with the short circuit to gate and no short circuit to the drain and source, I'm not going to bother ordering these at the moment, and because the car's not worth a lot of money, I'm just going to get these two. So you're like €5.56. Yeah, I'll order these, and just before I do that, I'll have a look on my graphics card. I do have one. I'm not totally sure it's the same brand as Zotac. I'll have a look at it in a minute. On the video, I'm going to link to you guys so you can all have a look at it in a minute and see if I can see what this other burnt out transistor or diode is. If not, I'll ask on Bad Caps and see if somebody's got one of these, and they can, like with the last one, they'll look it up and tell me what part to order. But the transistors will be very cheap once I find out what they are, I'm sure of that. Okay, so that's 3 looked at so far. This is the first one. I'd have to say nobody's been tampering with this. I don't believe anybody has previously worked on this, where the other two clearly had. Yeah. Okay guys, so we'll move on. All these parts I think are going to turn up pretty much at the same time, so we'll have a kind of a repair fest, but for now we've got some more we can work at. Okay guys, see you all soon now. Ciao for now.